Right now, inside your skull, your brain is holding on to garbage it cannot throw out. Every thought you've had today burned fuel, and burning fuel leaves waste, proteins, broken molecules, metabolic ash piling up in the narrow gaps between your brain cells. And here's the strange part. Your brain has almost no way to flush that waste while you're awake. The drain is closed. It stays closed as long as you're conscious. So here is the question this episode answers. Where does the trash go? Every other organ you have gets rinsed continuously by the lymphatic system, a body-wide plumbing network that carries waste away. Your brain, the most demanding tissue you own, was long thought to have no such plumbing at all. The obvious answer, that your brain just quietly cleans itself in the background, turns out to be exactly wrong. It cleans itself in the foreground of one specific state, and you are unconscious for all of it. Tonight, when you fall asleep, a demolition crew clocks in. It runs pipes that don't exist while you're awake, and it tears down structures you spent all day building. None of this is metaphor. It's fluid mechanics and cellular cleanup, and by the end of this you'll be able to name every part of it. Start with the plumbing, because for over a century, nobody believed it was there. The rule everyone assumed was simple. The brain is special, sealed, protected. It sits behind the blood-brain barrier, walled off from the rest of your body's messy circulation. Every other tissue has lymphatic vessels threading through it to haul away waste. The brain, textbooks said for decades, had none. It was the one organ that supposedly kept its own house clean by some vague, unlocated process. That rule broke in 2012 in a lab at the University of Rochester run by a neuroscientist named Macon Nettergaard. Her team found the missing plumbing not a separate set of vessels, but a system that piggybacks on the ones already there. They named it the glymphatic system, a mashup of glial and lymphatic, because it runs on your brain's glial cells, the support cells that outnumber neurons and do the janitorial work. Here's how it actually moves. Cerebrospinal fluid, the clear liquid your brain floats in, gets pushed down along the outside of your arteries into the deep tissue of the brain. It washes through the gaps between your cells, picks up the day's metabolic waste, and drains out along the veins, carrying the garbage toward your bloodstream and eventually your liver to be broken down. It's a rinse cycle. Fluid in along the arteries, dirty fluid out along the veins. And the astonishing finding wasn't just that this system exists. It was when it runs. In 2013, Nettergaard's lab published the result that changed the story. A researcher named Lulu Shi ran the experiment on sleeping mice, watching fluid move through living brain tissue in real time. When the mice were awake, the glymphatic flow was a trickle. When they fell asleep, it opened wide. The rinse ran roughly 10 times faster. The mechanism behind that surge is almost cartoonishly physical. During deep sleep, your brain cells actually shrink. The neurons pull in, and the space between them, the interstitial space, expands by around 60%. Overnight, your brain tissue loosens up like a sponge being wrung out and then held open. And the cerebrospinal fluid floods into all that new room and power washes the gaps. 60% more open space, appearing and disappearing on a daily schedule, tied to whether you're conscious. Your brain has two physical configurations, a dense daytime one for thinking and a loose nighttime one for cleaning, and it switches between them every 24 hours. Now, what exactly is getting washed out? A lot of ordinary cellular waste, but one item on that list is why this research went from a curiosity to a headline. One of the molecules the glymphatic system clears is beta amyloid, the sticky protein fragment that clumps into the plaques found in the brains of people with Alzheimer's disease. Your brain produces beta amyloid all day as a normal byproduct of neurons firing. Under healthy conditions, sleep rinses it out. But when the rinse doesn't run, the protein lingers. And in 2018, a team at the National Institutes of Health, led by Ehsan Shokri Kojori, tested this directly in people. They kept healthy adults awake for one night, then scanned their brains. After a single night of no sleep, beta amyloid had measurably risen in exactly the regions that are hit early in Alzheimer's. I want to be careful here, and we'll come back to how careful in a minute. One bad night does not give you a disease. But the finding drew a clean line between a thing you do every night and a molecule at the center of one of medicine's hardest problems. And it suggested that part of what a full night of sleep buys you is a clean drain. There's one more piece of proof, and it's the most beautiful, because for the first time it was filmed in a living human brain. In 2019, a neuroscientist named Laura Lewis, then at Boston University, put people inside an MRI scanner and had them fall asleep. What her team captured was almost hard to believe. As the sleepers dropped into deep sleep, large, slow waves of electrical activity rolled across the brain, and locked in rhythm with them, in perfect time, waves of cerebrospinal fluid came pulsing up into the tissue. Every 20 seconds or so, a pulse, electrical wave, then fluid wave, chasing each other all night. You have, quite literally, a tide that comes in only when you sleep. And now we know why it can't come in while you're awake. The pipes stay closed on purpose, and the culprit is a chemical you know by its effects. Norepinephrine, the arousal signal, the wakefulness molecule, the thing that keeps your neurons packed tight and alert and firing. As long as it's high, the interstitial space stays compressed and the fluid can't get through. Waking up, in the plumbing sense, means clamping the drain shut so you can think. Which reframes a feeling you already know. That thick, clogged, cotton-headed sensation after a night of bad sleep. The sense that your head is physically full may not be entirely in your imagination. You skip the rinse. The waste your brain made yesterday is still sitting in the gaps this morning, and the fog is what an undrained brain feels like from the inside. But cleaning is only half of what the demolition crew does tonight. The other half doesn't haul waste away. It tears down things you built today, on purpose. And this is where deletion stops being a figure of speech. Everything you learned today, you learned by changing physical structure. When two neurons fire together, the connection between them, the synapse, gets stronger, a little bigger, a little easier to trigger next time. That's memory at the cellular level. A conversation, a face, a route through a new building. Each one leaves your synapses physically altered, strengthened, grown. Here's the problem. You can't only ever add. If every synapse got stronger every day and none ever weakened, your brain would saturate. Connections maxed out, everything screaming at once. No contrast left between what matters and what doesn't. Strengthening is expensive. It costs energy and space, and it can't run in one direction forever. Something has to give the ledger back its balance. That something is called synaptic pruning, and the leading explanation for its timing comes from two scientists at the University of Wisconsin, Giulio Tononi and Chiara Cirelli. Their idea is called the synaptic homeostasis hypothesis, and it goes like this. All day while you're awake and learning, your synapses ratchet up, net stronger, net bigger. Then at night, sleep scales the whole set back down. Not evenly, proportionally. The connections get weakened across the board, so the ones that were strongest today survive the cut, and the weakest ones fade out entirely. In 2017, Cirelli and a colleague named Luisa De Vivo went looking for physical evidence, using an electron microscope to measure thousands of actual synapses in mouse brains, some after sleep, some after being awake. The synapses that had been through sleep were smaller. On average, they'd shrunk by around 18%. You can see the downscaling. It leaves a mark you can measure in the size of the connection itself. So picture what that means for a single day. You wake up, and over the hours you lay down thousands of new connections, most of them noise. The license plate in front of you at a red light, a stranger's coat, the exact wording of a sentence you'll never need again. By evening your brain is crowded with the important and the trivial, all strengthened together, indistinguishable by size. Then you sleep, and the whole field gets scaled down, and the trivial connections, the weak ones, drop below threshold and vanish. what's left standing in the morning is what mattered. And this is the paradox that makes the whole thing feel like loss. The forgetting is the point. It is not a failure of the system. It is the system working. The pruning is what makes memory usable at all. Think about what a memory would be worth if you kept everything. If today's grocery list were burned in with the same intensity as your child's face, if every overheard word survived as vividly as the thing you were actually trying to learn, you'd have a perfect recording and no meaning. Meaning is contrast. It's the difference between the signal and the noise. And you buy that contrast every night by deliberately deleting the noise, so the signal is the thing that's still there when you wake. You don't just consolidate memories in your sleep. You sculpt them, and sculpting is subtraction. The statue is what's left after you take away everything that isn't the statue. Now the skeptic's turn, because this is where the sexiest version of the story needs undercutting. And honestly, the true version is more interesting than the hype. The tidiest way to tell all this is sleep is for cleaning. Forgetting is for focus. One bad night ages your brain. Be suspicious of how clean that is. Start with the glymphatic system itself. Almost all the direct watch-it-happen evidence comes from mice, and a mouse brain is a very small, very different thing from the roughly 3 pounds of tissue in your head. Researchers have argued vigorously, in print, about how fast the fluid really moves, about whether it's a gentle diffusion or an active flush, even about how much of the clearance genuinely depends on sleep versus other rhythms. This is a young field, and it is still arguing with itself. That's not a weakness. That's what a live scientific question looks like. And the amyloid story deserves real caution. That one-night study showed a rise in a protein after sleep loss. It did not show that poor sleep causes Alzheimer's. The relationship almost certainly runs both ways. Bad sleep may let amyloid accumulate, and accumulating amyloid may itself wreck the sleep that would clear it. A loop that's genuinely hard to untangle. Anyone who tells you that a rough week of sleep is giving you dementia is selling you fear the data does not support. Then there's the deepest honesty, and it's about the pruning. We can see that synapses shrink overnight. What we cannot yet fully explain is how the brain chooses. How does a downscaling process that weakens everything proportionally manage to spare precisely the connections that carry the day's most important memory? What tags a synapse is worth keeping? There are real hypotheses, molecular markers left on the synapses that fired hardest, replay of the day's activity during sleep that reinforces the winners. But the full selection rule is not settled. The editor is real. We're still reverse engineering its taste. And I haven't even mentioned dreams. All of this, the fluid tides, the synaptic downscaling, is happening in a brain that for part of the night is also generating entire vivid worlds. Whether dreaming is part of the editing, a side effect of it, or something else running in parallel, is one of the genuinely open questions in all of neuroscience. Nobody can tell you, with real evidence, what dreams are for. The best scientists in the field will say that plainly, and they're more trustworthy for it. So let it land back on you, on the ordinary nights you've already lived through. You know the difference. There's the morning after real sleep. The world feels sharp, names come easily, yesterday's mess has quietly sorted itself into a shape that makes sense. And there's the morning after a broken night. Thick-headed, forgetful, the fog that no coffee quite lifts. You've always called that being tired, but now you can name what actually didn't happen. The tide didn't come in, the drain stayed shut, the editor never showed up to cut the noise, so the noise is still there this morning. The grogginess isn't your brain being lazy. It's your brain still holding yesterday, undrained, unpruned, unedited, waiting for a night it didn't get. Here is the reframe, and it's stranger than the story we started with. You've probably always thought of sleep as rest, as pause, as the 8 hours where nothing happens so you can recover for the hours where something does. But nothing about tonight is passive. Tonight your cells will shrink to open the pipes. A tide of fluid will roll through your brain in time with electrical waves, washing out the protein residue of every thought you had today. And an editor with taste we don't yet understand will walk the length of everything you learned and quietly delete most of it, keeping only what earns its place. You do not rest at night. You get taken apart. The waste gets carried out, the weak connections get torn down, and what survives until morning is a cleaner, sparser, more usable version of the mind you fell asleep with. You wake up lighter because you are, in a small and literal sense, less than you were, and better for it. And the strangest part is how ordinary it is. There is no effort in it, no attention, no you. Tonight it will happen again, on schedule, without your permission and without your notice. The most important editing of your life, done entirely while you're not there to watch.